Hello, here I will cover some topics from chapter 8.1, Trigonometric Functions of Real Numbers. A couple things I would like to mention. If you have a unit circle, then cosine of theta equals x, and secant of theta is equal to 1 over x. Therefore, cosine of theta is equal to 1 divided by secant of theta, and 1 divided by cosine is equal to secant of theta. So it's the entire operation of cosine, sine, secant. It's the entire trigonometric function that you are finding the inverse of. Not the inverse of the angle, but the inverse of the entire function. Similarly, sine of theta is equal to 1 divided by cosecant of theta, and 1 over sine of theta is equal to cosecant of theta. And the same thing with tangent. Okay. So when you find the reciprocals, you do the reciprocal of the entire function, not just of the angle itself. Some identities. So notice if we take and if we divide everything by sine squared theta, what we have is another identity. So sine over sine gives us 1, plus cosine over sine is cotangent. It's equal to cosecant squared theta. So this is another identity. There are an infinite amount of identities. If we were to take and divide everything by cosine, we will have sine over cosine is tangent. That's another identity. We can subtract cosine squared theta from both sides. This tells us that so many of these you will be just fine without memorizing them. If you don't memorize number 2 and 3, that's just fine. But 4 should be familiar looking. 1, definitely 1. Definitely 4. And then 5 is similarly, we're going to have and the reason why I say 2 and 3 you don't have to memorize is because a little side trick, we can just say that s plus c equals 1. Sine squared plus cosine squared equals 1. And then from here, we can divide everything by cosine if we want. Or from here, we can divide everything by sine if we want. Just a little side note to help us derive the less familiar ones, if you may. Even functions and odd functions. So remember that if you can remember the definition from even functions or odd functions, or if this is the first time seeing these, this is how they work. So even functions are defined as, the symbol is defined as or becomes. So even functions are defined as if f of x is equal to f of negative x. for all x in x. If that's the case, you have an even function. Odd functions are defined as f of x equals negative f of x for all x in x. Okay. Note that cosine of theta and secant of theta are even functions. We'll explore that in a little bit. All of the others are odd functions. Okay. Some more things we're going to cover. Page 539. Look up page 539 if you want to read it other than how I have explained it here. So sine of t plus 2k pi is equal to sine of t for all k in z. Z is just German for Zachlin, but z, let me show you what z is. So z are your integers from negative infinity, negative 3, negative 2, negative 1, 0, 1, 2, 3, and on up to positive infinity. Those are your integers. While we're on this topic, here are your rationals. These are your natural numbers. So your natural numbers are going to go from 1, 2, 3 on up to positive infinity. No zero, no negative numbers, and no fractions. So your Q will be the Zachlin over the natural numbers, your fractions. Okay, and there are more than just these. We have the complex numbers that you've seen before. These are your imaginary numbers. We have boldface R. These are your real numbers. And there are more classes of numbers, but these are what you will deal with mostly in calculus. So z are your integers. So what this is saying is for every integer, this situation happens. You can add 2 pi to any angle and you still have that same angle. Or you can also add any multiple of 2 pi, negative or positive. That's what this is saying. And this is intersection. And for all real numbers t, for all t in the reals. So that's what this is saying. This is saying that cosine of t plus 2k pi equals cosine of t for all k in z and all t in r. Read up on page 539 if you would like a different explanation. Okay, so to page 540 for some homework problems. So 1 through 8, it says evaluate each expression. Cosine of 2 pi over 3. So here we're looking at fractions. If this gives you any type of a reason to hesitate, convert that into a decimal. So we can convert this into a decimal by, we have 2 pi over 3. So we have pi in the numerator, we have radians. So we're going to have radians in the denominator, degrees in the numerator. So that the pi simplify out. And this gives us 180 divided by 3 is 60 times 2 is 120. So this is the same thing as cosine of 120 degrees. Okay, this is 30 degrees past our pi over 2. because 90 plus 30 is 120. Okay, so if this angle is 30 and this is a right angle, this has to be 60. Cosine is your x value. This is going to be negative 1/2. This is going to be radical 3 over 2 and a 1. So the cosine is negative 1/2. This is negative 1/2. Cosine of negative 13 pi over 4. So we can add multiples of 2k pi to this. So let's go with 16 pi over 4 is the same thing as 4 pi. 4 pi is when k is equal to 2, and 2 is an integer. So it is legitimate. Negative 13 plus 16, this is going to give us cosine of 3 pi over 4. And if you want to convert this into degrees using the same method up here, we will come up with cosine of 135 degrees. Okay. What does that look like on our triangle? So 135 degrees is going to be 90 plus 90 plus 45. And so we have 45, 90. This must be 45. 45, 45, 90 triangle. This should be familiar as 1. This will be radical 2 over 2 and a negative radical 2 over 2 because the x is negative in quadrant 2. Cosine is the x value that we want. So this answer is negative radical 2 over 2. Number 15 through 22, check that both sides of the identity are indeed equal for the given values of the variable t. Okay. So here we're going to verify that both sides are equal. This is telling us we're looking for saying that when t is 3 pi over 4, we want tangent of 3 pi over 4, and then whatever that is, we're going to be squaring it. Plus 1 is equal to secant of 3 pi over 4, whatever that is, we're going to square that. 3 pi over 4 is this configuration. So tangent of 3 pi over 4 is going to be sine over cosine, negative 1. So this is going to be a negative 1 squared plus 1 is equal to secant is the 1 over cosine. So secant is 1 over cosine. It's going to be the inverse of the cosine. Now, I'm not going to rationalize that denominator. Yes, I can, and I should for a final answer. But since this is in my scratch work, it's okay to leave it like that, and I will leave it like that since I'm squaring it. Okay, so we have 1 plus 1 is 2, and this is going to be negative squared is positive, so this would give me 2 squared is 4 over radical 2 squared is 2. And yes, that does check out. 2 is 4 over 2. negative 2 pi over 3. So negative 2 pi over 3, let's add 6 pi over 3. This tells us that because if I add 6 pi over 3, I get 4 pi over 3. Okay. And this as a degree. (180) divided by 3 is 60. 60 times 4 is 240. Where is 240? 240 is going to be in quadrant 3. And this is the case because 240 degrees is going to be 180 plus 60. So 180 plus 60 is 240. And 60 plus 30 is 90. So this has to be a 30, 60, 90 in this configuration. Okay. 30, 60, 90 will give us 1/2 negative because of the quadrant. Radical 3 over 2 negative because of the quadrant. Hypotenuse of 1. Okay. And then look to answer. Tangent of that value is the sine over the cosine. Negative over negative is a positive, so tangent is going to be positive radical 3. Tangent is mean squared plus 1 is equal to secant is 1 over cosine. Cosine here is negative 1/2, so secant is going to be negative 2. And we're squaring that. Okay, 3 squared is 3. 3 plus 1 is 4. 4 is 4, and that checks. Here we are just checking that these make that. Here we are just checking that these are identities. We're just checking some of these values and variables. So try it on yourself. Try radical 5 in your calculator and to verify that this will equal, both sides will balance. Thank you very much. Please go to tutoring.